A colorful morning to one and all. In the last section, we have started motion and its type. In motion and its type, we have discussed about translatory motion, circular motion and rotational motion. In today's section of class, we are going to discuss about periodic motion and oscillatory motion. What is periodic motion? If the motion of a body repeats at a fixed interval of time, then such motion is known as periodic motion. We are going to see with some examples. For example, let us consider this is a clock. So we already know that in the clock 3 hands will be present, that is seconds hand, minutes hand and hours hand. If you take the seconds hand, this seconds hand for every 60 seconds it is going to repeat its motion. So such motion is an example for periodic. So for every 60 seconds it is going to repeat its motion. So such type of motion is known as periodic motion. When the second sense comes to here, all the parameters, what are the parameters? It may be related to velocity, it may be related to acceleration, it may be related to force. All the parameters will be same. The direction is also same when the second hands reached here. In the same way, if the second hands reached here, when after completion of its one oscillation, one round, when it comes here, at this point also, all the parameters will remain same. Now we can say another way, the definition of periodic motion. The motion in which all the parameters of the body remain same. Such motion is also known as periodic motion. So this is an example for periodic motion. In the same way, if you take sun and earth, system, we know that the sun is going to remain center. Basing upon this sun, the earth is going to revolve in elliptical path. So the earth is going to make periodic motion. How means? The earth, in order to complete one revolution, it takes 1 year. That is nearly 365 days. For every 1 year, it is going to repeat its motion. So this is also an example for periodic motion. Earth moon system, that is sun and earth, it is also an example for periodic motion. In the same way, if you take another example, let us consider it is one of the depression. Now, if you release a body here, from here, if a marble or ball, this ball is going to comes down and it is going to reach the same height up to here. And once again, it comes down. In this way, the ball is going to make its motion. So it is going to repeat at a fixed interval of time. So this is also an example for periodic motion. Some more example we are going to discuss. The best example is simple pendulum. If you take simple pendulum, what is simple pendulum means? It will have a rigid support. To this rigid support, we are going to suspend a thread or a string. To the end of the string, we are going to attach one bob. This entire system is known as simple pendulum. Once again, I am repeating. This is a rigid support. To this rigid support, we are going to suspend a string or a thread. To the other end, we are going to attach one small bob. Okay. Now, if you pull this bob aside like this, if you pull this bob aside and release, it makes oscillation like this. It makes to and fro. So this is also an example for periodic motion. Here the bob is going to make its repetition, its motion at a fixed interval of time. So this is also an example for periodic motion. Periodic motion. If you take another example, if you take a string, if you take a fixed support, to this fixed support we are going to attach a spring like this. To the other end of the spring we are going to add a small block of mass m. If you pull this block a little downwards and release, it is also making some movement. This movement is also considered as periodic motion. It is going to repeat its motion in fixed interval of time, so its motion is also considered as periodic motion. These are all the examples for periodic motion. Now we are going to see the another type of motion, that is oscillatory motion. So in order to discuss about oscillatory motion, we want to know the definition of oscillatory motion. So what is oscillatory motion, we are going to see. Right, now coming to the oscillatory motion. What is oscillatory motion? When the motion of a body is said to be oscillatory means, if a body makes to and fro on the same path about a fixed point. So what is to and fro means? Forward and backward. If it makes to and fro means forward and backward. If a body makes forward and backward on a same path about a fixed point, then such motion is known as oscillatory motion. Now in these examples, we are going to see which body is making oscillatory motion. Here, if you observe the movement of this second's hand or hour's hand, it is not making to and fro. It is going to repeat its motion, but not making to and fro. So it is not oscillatory motion, it is only periodic motion. When you come to the earth, here the earth is also moving around the sun. It is not making to and fro. So it is also not an example for it is also not an example for oscillatory motion. It is an example for periodic motion. When you come to here, that is depression. Here the body, it repeats, okay? It is repeating its path, so it is making to and fro. So it is also an example for oscillatory motion. Here also, it is making to and fro. What is to means? It is moving forward and backward. Once again, it is moving forward and backward. This is fixed position. There is mean position. Basing upon this mean position, it is making to and fro. So it is also example for oscillatory motion. It is a periodic motion as well as oscillatory motion. When you come to here, it is also making to and fro. So this is fixed position. Basing upon this fixed position, if you pull down and release, it is going to move up and down. So it is making to and fro. Here on the same path, it is important. Here the path is same. It is not changing its path. On the same path, it is making to and fro. So it is an example for periodic motion as well as oscillatory motion. Here also, it is an example for periodic motion as well as oscillatory motion. So from this, we can confirm that all the periodic, here the periodic motion, but it is not oscillatory motion. But when you come here, it is oscillatory motion as well as periodic motion. So there are some examples which are oscillatory motion as well as periodic motion. These are the examples only for periodic motion. Now we are going to discuss some more terms related to this simple pendulum. Now we are going to discuss some more terms related to this simple pendulum. Now we are going to see some terms related to the simple pendulum. Already we know what is simple pendulum. Now this is a thread. From here to here, it is known as the length of the thread. Length of the pendulum. Length of the pendulum. This is mean position. This is extreme position. This is also extreme position. So when we pull this bob and release, it is going to make to and fro, to and fro. That means it moves to extreme position, and once again it comes to mean position, and once again it going to extreme position and comes to mean position. Now we are going to see some terms related to this pendulum. The first one is amplitude. What is amplitude? Means the maximum displacement made by the oscillating particle on the either side from mean position. Remember this? Maximum displacement made by the particle from fixed position. From fixed position on either side. Now if you are going to release this bob, it is going to move here, up to here only. This is the maximum. So this is the boundary. After that, the bob is not going to move. So from here to here, we considered as amplitude. So from here to here. So in this way, on this side, if you come to this side, this is the maximum position. Up to this only the bob is going to move. After that, it is going to return, comes back. So this maximum displacement. This is mean position. From this mean position, the maximum displacement, it is known as amplitude. Here also, it is known as amplitude. For example, if the bob is here, we should not say it is amplitude. It is just, it is making some displacement. So when we are going to say amplitude means the bob should make maximum displacement. Then the bob is said to be having amplitude. If you consider the bob is here, we should say it is having some displacement. So amplitude, the unit to measure amplitude is meter. The unit to measure amplitude is meter. So this is about amplitude. Now coming to another term related to the simple pendulum, that is oscillation. So we are going to discuss about oscillation. When we are going to say it complete one oscillation means, here there is a condition. We are going to discuss about oscillation. When the bob is said to be completed one oscillation means, here it should satisfy two conditions. The first one is position should same, velocity and direction should also be same. So if it satisfies these two conditions, the position and the velocity and the direction should be same, then it is said to be completed one oscillation. How? We are going to say. For example, if you pull the bob from here and release. Let us consider the bob has reached here. After moving to extreme position, once again it comes to mean position and the bob has stopped here. Whether we are going to say it completed one oscillation, we are going to see whether it is going to satisfy these two conditions or not. So it has reached same position. Here the position is same. But when you observe the direction, the velocity, when it is moving, the direction of velocity is like this. When it returns, the direction is here, opposite direction. So we does not consider it makes one oscillation. When we are going to say it is making one oscillation means if the bob reaches here. So if you pull like this and release here, it is going to move to extreme position and once again it comes to mean position and it reaches to extreme position. Then it is said to be one oscillation. Why means when the bob reach here, the position is same. We have released from here only. So the position is same. And the velocity is also same. Direction of velocity is also same. Then the bob is said to be completed one oscillation. When bob is here, the position is different. Why means we have pulled the bob here, but the position we have taken is here. So it is not having the same position. At the same time, the direction and velocity is also different. So when the bob is here, we cannot say that it is completed one oscillation. If you pull the bob from here, then it is taken as one oscillation. So we have pulled the bob from here and we are going to take as a completed one oscillation here, so we should not take. So this is about oscillation. Next, coming to the third term, time period. Time period. What is time period means? The time taken by the bob to complete one oscillation. In order to complete one oscillation, that means from mean position, we have pulled the bob to extreme position. When we release, it reaches to the mean position. Once again, it is going to reach to the extreme position. Once again, it comes to the mean position. And once again, it reaches to the extreme position. Then it is said to be completed one oscillation. In order to complete one oscillation, it takes some time. That is known as time period. Remember, the time taken to complete one oscillation is known as time period. So, time period, the units for time period is seconds. The unit for time period is seconds. So, what is time period? The time taken to complete one oscillation. Last parameter, that is the last term related to simple pendulum, frequency. What is frequency? Means hit the reciprocal of time period is known as frequency, or the number of vibrations made per 1 second. So in 1 second, how many oscillations it has completed? It is going to be determined by frequency. Simply we can say the frequency is the reciprocal of time period. So this is very important formula in order to calculate the numericals. So what is the relation between frequency? It is denoted by the letter F, or sometimes it is denoted by the letter N. F equal to 1 by T. Or sometimes we can write the number of vibrations per seconds. The number of vibration per second. So F equal to 1 by T. What is the unit of frequency? Hertz. So the unit of frequency is Hertz. Okay. It says how fast the pendulum is moving. How fast the body is making its vibration is going to be determined by frequency. Okay. So these are the terms related to the simple pendulum. Now we are going to do a small problem basing upon time period and frequency. We are going to see a small problem basing upon the time period and frequency. Here the problem is a body completes 15 oscillations in 30 seconds. Calculate its time period and frequency. We already know that time period. It is the time taken by the body to complete one oscillation. But here it is given that to complete 15 oscillations, it takes 30 seconds. Now, we want the time period for single oscillation. So, time period for single oscillation. For one oscillation or single oscillation. So, how we are going to calculate? For 15 oscillations, it takes 30 seconds. So, for one oscillation, it takes, 2 seconds. How? That is 30 by 15. So, 15 ones, 15 twos. So, 2 seconds. So, the time period is 2 seconds. Now, we want to calculate frequency. We already know the formula related to frequency and time period. What is the relation between frequency and time period? Yes, F equal to 1 by T. The reciprocal of time period is known as frequency. F equal to 1 by T, that is 1 by 2. What is the value of 1 by 2? 0.5, right. That is 0.5. What is the unit of frequency? Hertz. So this is how to do the problem, simple problem basing upon time period and frequency. So with this, we have completed the motion and its types. In next video, we are going to come with next topic. Until then, have a good day.